All right, I guess we'll just jump right into it. Any questions about anything before we start? Okay. Okay, so we're going to keep going on security policies. Now we're going to look at two technical policies. They're related to each other. They're both policies that are implemented by a web browser. Okay, so web browsers are pretty old. They go back to the 90s, and there's certain policy decisions that you need to make when you're designing a web browser, and these are the kinds of policies that were made in the early 90s. Okay, they might not have been. The two that we'll talk about weren't really in like 1990, 93, but they were like around 94, 95, 96, okay? And the web has like changed a lot since then, and the way that websites are constructed has changed a lot. Early websites were very simple. It's usually just an HTML page, maybe some styling, maybe some images, maybe some links. It wasn't really implementing things like cookies to trace you. It wasn't really weaving together content from multiple sites. It wasn't doing a lot of active content in terms of JavaScript and earlier things like ActiveX or Flash or those types of things. Okay, and nowadays you can see, so Chrome is the most popular browser, and then the default browsers in Microsoft and Apple are next. You have Firefox, and then a couple others. This, by the way, is for computers, so on a phone it's going to look different. Safari would probably be a larger percentage if you considered phones. Chrome would be a large percentage. Basically, Android users are going to use Chrome. iPhone users are going to use Safari, unless if they've installed Chrome as a third-party app. And Microsoft, I don't think, makes phones anymore. Okay, so Netscape Navigator was one of the earlier browsers. We talked about Netscape Navigator before in one context. When we talked about SSL, we talked about 40-bit keys, and there was a sort of story about the government regulating that. So that's the same Netscape. Today, Firefox is kind of a descendant of Netscape. So going from Netscape to Mozilla to Firefox there's a bit of a provenance there, but it's I would say Firefox is exactly Netscape, but there was some transfer of some of the code. Okay, so Netscape made two important decisions in the early days of the web. One was what cookies are, and the whole like policies and procedures around cookies. That was made in '94. And then a year later, they decided, what should we do about active content that wants to run on a website? Who owns it? Can it see the website? Can the two scripts running on the same site, can they see each other and talk to each other? Like, how do we isolate basically scripts that are running? And so they came up with this thing called the same origin policy. So today's class will just talk about the cookie policy, and next class we'll just talk about the same origin policy. Both of them ultimately, this idea of origins, like where are you getting a cookie from or where are you getting JavaScript from, is important. So there's an overlap between these two policies. They're similar, but they're used for different purposes. And there's attacks that are a direct result of the policy decisions that were made by browsers, which is why this is going to be the running example for the next two lectures. Okay, so we talked about this before, but just as a reminder, you have a website. A website consists of a bunch of resources, okay? You have resources that are in the content of the page, and here it's useful to distinguish between passive resources, which are things that can't run code. They can't execute. So images, HTML, an audio file, a video file, that type of thing. And then things that can actually run. Okay, JavaScript is by far the most important one. CSS is how you style a website, like you can define the fonts and the layout and the margin and things like that. CSS should be passive content, but it's sort of treat it as active content because as the language has become more verbose, you have the ability to do fairly complicated things that are bordering on execution. So for safety, we just treat it as active content, even though it's really just a markup language originally. XML HTTP request is something I guess we'll come back to, but it's just, if you have JavaScript, one thing JavaScript is allowed to do is open an internet connection to any website. So it can go and grab whatever resources it wants from anywhere on the web. And the way it does it is different than how the browser does it. So if you tell your browser to do it, it will use one kind of method. It will look a certain way. If JavaScript does it, it will look slightly different. You may want to block one or the other. Okay, that's why it will be relevant. Then in addition to the content, you have like metadata or the headers of the content. So content, think of like a website giving you something in an envelope. So the website, all the images, video, all that stuff, they come in envelopes. And on the outside of the envelope, there's some information that's written. Okay? So the main thing that headers are used for are cookies. So cookies aren't inside a website. There's something that's written on the outside of the envelope that's giving you the website. There's other things too, like when your browser requests a website, it might say, hey, I'm Safari version whatever. And then when the website receives that, it can see that that's written on the outside of the envelope. It might decide, because this person's on Safari and not Chrome, I'm going to do something slightly different. Like I'm going to use this font instead of that font. Sometimes there's referrers. So if you click a link on website A and you go to website B, going to website B means that you request website B from website B's server. And when you send that request to website B, you might write on the outside of the envelope, hey, I was sent here from website A. Okay, then B sort of knows it. They know where you're coming from. And so it's just a way of sort of passing that information on. Okay, so that's called a referrer. And there's tons and tons of stuff in headers. So you can go through them. None of them are relevant for today's lecture other than cookies. That's the only one that we're going to talk about. So basically we have passive content. Next lecture we'll talk a lot about scripts. This lecture we'll talk about cookies. And there'll be a small piece of this lecture about XML HTTP requests. Yeah. So the format of the request is different, but it's not really an important thing. It doesn't really matter for the purpose of this course that they look different. It's just that they're coming from different places. So what we will see later is there's an option for cookies where you can say, you're trying to decide whether to send a cookie or not. And you might say, only send this cookie if the browser's requesting it, never send it if JavaScript's requesting it. Or conversely, you might say, send it regardless. So that's the distinction that's made. Yeah. Yeah. Okay, so we can think about the security goals. Any policy has some goals you're trying to achieve. Basically, we want the browser policies to, and this applies to next lecture and this lecture. It's maybe this one's more for next lecture, but whatever the website is sending to the user, it wants to know that that's what the user's seeing. Okay? If it starts mixing content in like JavaScript and then the JavaScript's overwriting what's on the website and things like that, that's like something that we don't want to happen. Okay, so the developer wants to be able to control exactly what the user sees when the user is asking to see a website from that server. There's some privacy information. So if you, or privacy considerations, if you're blending together things from different websites, you want to think about whether, like say I put a Facebook like button on my blog. Does that mean Facebook can see the blog? Like what does it know about it? If I type my username password in to log into the blog and there's a Facebook like button on the page, does that mean Facebook can read my password? Okay, so like the answer to that obviously should be no, but we need some policies to make sure that like why exactly is that the case? Okay, so that will be something else that's covered. And yeah, so those are the two. Okay, now let's consider a little thought experiment just to sort of warm up. So I go to Gmail. It asks me to log in. That's great. So I give my username and my password. I send it to Gmail. Gmail has a password database. They look at it. They say, yes, this password is correct. They log me in. They send me my inbox. Okay, so now I'm looking at my inbox. Now I want to click on message number 1 in my inbox. Okay, does Gmail ask me to log in again? Does it ask for my username password? Why not? I already signed in, but how does it know I'm the same person? Okay, so because of a cookie, so what does that mean? So it's related to cookies? Okay, so we have this concept at a high level. We've heard about cookies. You've seen them in assignment 2. You might not know exactly the specifics of them, but this has something to do with cookies. It has to do with user sessions. So user sessions are basically a subset of what you can use cookies for. So you can use cookies for a bunch of stuff. The biggest one that you can do is to establish a session. Okay. Okay. Okay, so we're going to go through exactly what cookies are and how they work. Because I happened to, a very long time ago, I did this video for Concordia because they wanted like an explainer on cookies. I thought I would show it to you. It won't tell you how cookies work, but it's fun just to watch, and then we'll talk about cookies themselves. I'm just going to see if I can get the sound to work. Most of us think of Google as a search engine, but okay. Most of us think of Google as a search engine, but it's also an ad agency. Hi there, I'm Jeremy Clark, a professor at the Concordia Institute for Information Systems Engineering. Today we're going to demystify internet cookies. So all of you have certainly heard about the delicious types of cookies, and most of you have heard about internet cookies. To help understand this concept, I'm going to tell you a little story about Alice. So let's say that Alice gets a brand new tablet. She opens a box, turns it on for the very first time. At this point, she's completely anonymous. She decides she wants to go and find some boots to buy. So she goes over to Google, and at this point, a cookie's born. Think of a cookie as a serial number that websites assign to their users to track them around their platform. As Alice looks through her search results, she notices a pair of boots from her favorite shoe store and clicks on the link. By default, a cookie from one website can't follow you onto another website. However, Alice's favorite shoe company, like most of the top million websites, has a business relationship with Google. This allows Google's cookie to follow Alice through the virtual doors of the shoe store, like a little digital stalker. Alice gets bored of looking for boots, so she decides to go over to a message board to chat about her favorite show, Black Mirror. On the message board, she sees an ad for the exact boots she was just looking at. So what's going on here? Most of us think of Google as a search engine, but it's also an ad agency. The chat room in this case has outsourced its ads to Google. And because Google has a cookie that followed Alice from the search page to the shoe site and now to the message board, it knows exactly what ads it can serve to Alice that she's likely to click on. Using cookies in this way is prevalent on the modern web. Of the million most popular websites, Google can trace you across about 50 to 80% of them, while Facebook can track you across a third. Now, all of this may sound very scary. You should know that cookies are primarily used for advertising. However, there are more nefarious uses. For example, websites have started selling digital dossiers to political campaigns for micro-targeting. Now, you may be wondering what you can do to stop this. The truth is, it's pretty much impossible to live a cookie-free existence, as cookies also serve practical functions that make the web easier to use. However, there are some small tweaks you can make to your browser settings to help protect your privacy. First, you should disable third-party cookies. Second, you should enable Do Not Track, which prevents companies that are compliant with Canadian law from using cookies to trace you.
The third thing you might use is private browsing mode, which gives you a fresh identity, sort of like when Alice turned on her new tablet for the first time. And this is why digital privacy is such an important issue moving forward. And that's how the cookie crumbles.
All right. Okay, so all the advice at the end of that basically is sort of old now. Like, you don't have a do not track option, I don't think, in Safari anymore. Now websites ask you about cookies, so that the law has sort of shifted the onus onto the websites themselves to establish a policy, and now you see it all the time when you go to websites like Concordia's or whatever. They're always asking about not just whether you want to allow cookies or like what type of cookies you want to allow and things like that. So hopefully at least at the end of this lecture you'll be able to answer those questions better. But okay, so let's go through at a technical level what it is. So a cookie essentially is just a number, okay? Who chooses the number, who stores the number, when's the number passed back and forth. So actually, okay, so it's precisely, it's a key value pair. So a key means there's a unique identifier and then the value is the number, okay? So the website that you visit is the one that creates the cookie. So cookies are not created by your browser, they're created by the websites. So you go to a website for the first time, you have 0 cookies. Then the website has the option, if it wants to create a cookie, and when it sends back the first thing that you requested, the first response, it can basically tell your browser, hey, you should keep a copy of this cookie. Okay? So that's how you get cookies in the first place. Now what the browser will do is it will say, okay, I just got this cookie. This was the website that I got it from. Okay, so it's going to record basically where did it come from, or it's going to at least look at that information. Okay, so that's called the origin, where you got it from. And it will store the actual key value pair. Now, in the future, when you, at a high level, go back to the same website, your browser is going to check and see whether that website ever sent you a cookie. And if it did, it will add it in to all your requests going to that website. Okay. Now, there's a little bit of red tape about what does it mean to go back to the same website. So we'll go through the details of that. But just at a high level, that's basically it. Okay. So a cookie is a number. The website chooses it. It tells your browser to keep it and to send it back every time you come back to the website. Okay. So when I go to Gmail, I put in my username password. Gmail says, here's a number. It's a long number. No one could guess it. And my browser stores it. And then when I click on the first message in my inbox, my browser sends that same number back. All of this is over TLS. Okay, so it's all protected. So no one in the middle could know what that number is. Google will look at the number and say, okay, I know who this person is. Okay. Why does it need cookies? Couldn't it just do IP address? Like if when I click on the first message, I come back from the same IP address? Okay, so you could spoof an IP address. You could also have multiple users using the same IP address, right? So all of us in the room might be on Gmail, and the router might put us all behind the same IP address. So Google sees, 20 people accessing Gmail at the same time, all from the same IP address. It doesn't know which one of us is which. Okay. Same with MAC addresses. You can't. First off, you don't really expose that end to end. That's more for between you and the next hop in the network. But at the same time, you can spoof it and things like that. Okay. So that's why we use cookies to establish sessions. So a session really is just the user returning with the same value and Google having written down what that value is and checking it. Okay, now when does the browser decide to send the cookie or not? So you get one from Gmail. Every time you go back to Gmail, it's going to send the cookie, right? Probably. What if you're going to Google search? Well, Google search is part of, Gmail's part of Google. Google search is part of Google. Is it going to send the cookie then? Okay, so this is why we need a policy. So we need a policy to write down when do you send it and when don't you send it. And a policy also gives the website some control. So the website's able to choose when it should be sent or when it shouldn't be sent. So it's not a black and white, like this is how cookies work exactly. You have some flexibility where websites can have cookies sent more often or less often, depending on what they're trying to achieve with the cookie. Okay, so this is sort of the same information, just in picture form. So I go to Gmail for the very first time. What that means is I'm sending a request to Gmail, okay? Brand new computer, never turned it on. I don't have any cookies, so there's no cookies being sent. Google will say, okay, I don't know who you are yet. You haven't logged in, but I'm going to create a cookie for you anyways. I'm going to create a value, and I'm going to send it to your browser, and I'm going to ask you to store it. And then every time you come back to me, you're going to send that value to me, okay? So the middle entry in here is just sort of like, there's some user, I don't know who they are. I'm going to send them cookie number, or the value I'm going to send them is D483, blah, 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 blah. Okay, so we can call this the session ID, or the identifier of the session. It needs to be unpredictable. Why does it need to be unpredictable? Well, if I can go back to Gmail with your cookie value, then Gmail will think I'm you. Okay? So cookies are kind of like passwords. Okay, you need to protect them. We have to send them over HTTPS. If we don't send them over HTTPS, then someone can pull them out and reuse them. And if I steal your session ID, and then therefore I'm you, I don't even have to log in. I'm already logged in. I just go to the website and it's like, okay, I know who you are. We call that session hijacking. So you might have heard the term session hijacking. What does that mean concretely? It just means I stole your cookie value. Okay. All right, and then we need to encrypt the cookies as well. Okay, so I send my request. Gmail's like, I don't know who you are. I'm going to create a cookie value for you, and I'm going to ask your browser to store it. I'm going to put that in the header of the response. So the response would be like the login page, like welcome to Gmail, put in your username, password. That's the response itself. It's that HTML page. And then on the outside of the envelope, they're going to tell my browser, or Alice's browser, set cookie. Remember, it's a key value pair. So the key for the cookie will be SID for session ID, and then the value of the cookie will be this particular number. Okay, and so we need to encrypt these values, and if we don't encrypt them, then someone could grab the session ID, and once they know it, then they can log in as you. So there's a story, just I'll tell briefly. It used to be the case that not a lot of websites use HTTPS. Then there was a phase where people started worrying about passwords. What if my password gets grabbed out of the middle? And so what websites would do is they would put you on HTTPS to take your password off of you. And then once you're logged in, they would redirect you back to HTTP. Okay? So the login would be over HTTPS. Someone in the middle can get your password. Then they would flip you back to HTTP. So big like social media sites might work this way, like Facebook was popular at this time. Okay, so Facebook would be a website where you would log in over HTTPS, but then you would flip back to HTTP. Now the problem here is you still have this cookie value that's being sent back and forth, and if I can get your cookie value, I can basically log into you as you. So it's almost as good as getting your password. It's not quite as good as getting your password, because your password, I can impersonate you forever until you change your password. A session ID eventually will expire, or the website will expire it, or the website might decide that even though I have the right session ID, because I'm coming from a different country at the same time that the user is logged in, that it looks suspicious and they might ask me for my password. Or I might go into some sensitive settings, like I want to change my password, and then it might say, okay, you can change your password, you have your cookie value, so I sort of know who you are, but because this is an extra sensitive security task, I want your old password at the same time. So there's certain things that you cannot do if you session hijack that you could do if you steal someone's password, but more or less they're kind of the same. Now the big problem is when Facebook was running this way, is, let's say I wanted to session hijack your session to Facebook. Well, how do I get myself in the middle, right? I need to be like an elite hacker to do that. Like, it's possible. Everyone understood, hypothetically, it's possible. But it's not like an everyday person could just put themselves in the middle of your connection, deep inspect the packets, grab that cookie value out, construct a new packet with the new cookie in, and send that off to Facebook. Like, it's theoretically possible, but it's not like something that like most people could do. Okay? So then what happened is someone said, actually, this isn't so hard to do if you're on the same Wi-Fi router as someone else. Okay, there's ways where you can sort of poison the routing table of Wi-Fi, and you can get all the traffic running through your computer. And then once it's running through your computer, then you have to figure out how to do it, but you can write the code for grabbing the cookie out and then inserting the cookie into all future things. Okay, so somebody coded this all up, and they released it as a browser extension for Firefox called Firesheep. And it was, if you wanted to use this, all you would do is you would go to the Firefox store and say, I want this extension. And that's it. And then you would have a little button, a little icon of a sheep. And what you would do is you go to Starbucks and you would connect to the Wi-Fi, and you would just press the button in your browser extension. And then there would be a sidebar that opens up and says, okay, right now I see this person's on Facebook, this person's on Twitter, this person's on Flickr, this person's on Google. And if you want to be this person, you just double click their name, and then boom, you're looking at their Facebook page logged in as them. Okay? So they took something that was theoretically possible, and they made it so that anyone could use it. You don't have to be a hacker anymore. You can anybody could use it. So anyways, this was all over the news when it came out. And then websites immediately, well, not immediately, but as fast as they could, they switched to HTTPS all the time because of this. So because this attack, it made it so easy to do, then the web completely changed. And so now, like, everything over Facebook, everything over Twitter, all social media is always over HTTPS. You never drop back down to HTTP. And so this probably did more than anything else. Between this and like the Edward Snowden revelations, those were the two things that really drove the web towards HTTPS. And now, even if you go to Concordia's website, it's over HTTPS. Like, just, you're not logged in or anything. You want to just look at the landing page of Concordia, it's over HTTPS, right? So, and eventually it'll probably be just a default where every website is over HTTPS. Okay, so back to our story. So I send the request. Gmail creates a cookie in their database so they can recognize me in the future. And they ask me to store the cookie on my browser. So I have this thing called a cookie jar. And I have a bunch of websites, and I have the cookies that I've saved already. And what I'll do is I'll add this cookie to the cookie jar. Okay, so I'll say mail.google.com gave me this cookie. It's called SID, and this is the value of the cookie. All right. Then what I'll do is I'll go back to Gmail. Like, I'll click on something. Maybe I log in. So I type my username, password. I press enter. That's going to send another request out to Gmail. And what my browser is going to do is it's going to nab it in the middle. It's going to say, oh, you're about to send a request to Gmail. Let me look at that really quickly and see if I have any cookies that match. Okay? So it sees the request is going to mail.google.com. It goes through my cookie jar, and it says, oh, I have this cookie for mail.google.com. I'm going to toss it in to the request, and then I'll send it on. Okay? So it puts the request in. So this is what Gmail receives. It receives the request from me, say with my username and password, and it has this cookie that came along with it. And so it knows that this second request is from the same person as the first request. Okay? So it can link those two actions together. It knows it's coming from the same user. Okay? It doesn't know who I am because I haven't logged in yet, but it knows that I'm the same person that had sent this first request. Okay? And as long as I keep this cookie around, and as long as Google decides to keep this cookie around, then Google will always recognize me as being the same person. Okay, so anything like, say I go to a website and it's in French and I say I want it in English, the website can remember that by giving me a cookie that just says this person wants it in English. Every time I go back to the website now, I send that cookie along, my browser throws it in, and so the website receives it and it says, oh, this person wants the website in English. And then they'll give me the English version instead of the French version. Okay? So cookies are a way of sort of making decisions sticky across multiple visits to the same website. Okay, is there questions about this so far? Okay. Now, let's say at some point Alice comes back and logs in. So she sends her username and password. She keeps sending this cookie. Basically, every request that goes to this website will have the same cookie. Now Gmail will say, okay, well, first it's going to check Alice's password and say, okay, this is Alice. And then it's going to say, interesting. Now I know who this cookie belongs to, right? So Alice had visited my website maybe before from her phone, and I had sent her this cookie, but she just got a brand new laptop, so that's why she's not sending this cookie. Remember, when I say this cookie is in your browser, it's in the browser on a device. So if I go to Gmail from my computer, if I go from my phone, I'll have different cookies for each of those, okay? But now that Alice has logged in, then Google will say, okay, I know that this is Alice because I can see her password is correct. And so I know these two cookies belong to the same person. And then any history it has about anything that Alice has done in the past, it now knows, well, this new person that I didn't know who it was, that's Alice. And so everything that they've done, I can merge those two histories together. And so now I know everything that this person's done. Okay, so questions about that? Okay, so yeah.
This is like at later time or?
Yeah, exactly, yeah. So think of it as you send some requests, they don't know who you are, so they just know you as cookie blah, 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 right? And then at some later point, you log in. And your login contains your cookie, the cookie where they don't know who you are, right? Your browser's giving that cookie value, plus you're saying who you are in the same thing. So you're asserting who you are and you're labeling this like unknown cookie on the outside of the envelope. Now Google, assuming the password's correct, then they're going to be able to put all of that together and say, okay, I know who this person is. Yeah. So what that means is, let's say you go to a website 100 times, and on the 101st time you log in. Does the website know everything that you did the 100 times before you logged in? And the answer is yes. So it can set a cookie the first time you go, and then when you log in, it will just merge, all the records it's been keeping before it knew who you were, and you were just a cookie, with the records of now we know who you are. Yeah.
Like nowadays, browsers also have a login. So doesn't it, like logging in my browser in my phone, the cookie jar on my phone can be also transferred to the browser on my computer if I log into my browser.
Okay, so you're saying, can you sync the cookie jar between browsers on a computer and browsers on a phone? As far as I know, I don't think any of the browsers sync the cookies. They might sync the saved password or something like that, but I don't think they sync the cookies. Could they? In theory, they could for sure. But generally, like a lot of the cookies you set are like, because it's from a phone, then the website is going to ask for the mobile version, and it's going to set a bunch of cookies so that when you go back, it will send the mobile version. So in general, you don't actually want to synchronize your cookies across devices. You want them specific per device. Yeah. Other questions? Okay, so cookies are something that, because they're in your browser, you can control them. Okay, if you want to go into your cookie jar and delete things, you can delete them. If you want to tell your browser never store any cookie, websites will keep asking you to store them and you'll just never store them. Or maybe you store them and never forward them. If you ever want to empty your cookie jar, you can empty your cookie jar. If you want to temporarily empty your cookie jar, you can open up private browsing mode. So private browsing mode just is an empty cookie jar. That's all it is. It's a fancy name for something that's just an empty cookie jar. Okay. Then as you browse in private browsing mode, you will still add cookies. So the cookies will get added to the cookie jar in private browsing mode. But then as soon as you close that browser window, it will delete all those cookies. Okay. So you can, it's not like, it's different than turning off cookies. Turning off cookies means you don't use cookies. Private browsing mode is just resetting your cookies so that it's blank, but then you'll start collecting them as you browse with it. And then you'll delete them when you're done browsing. Okay, third-party cookies, I guess there's a typo in the slide. I'll show you exactly what they are in a second. You can clear your browsers at any time. I was just saying you can block, if you want to block third-party cookies but not first-party cookies, then that's fine as well. But we'll say what that means in a second. You can do things like every time I close my browser, clear my cookie jar. Now, some of these settings, they're good for privacy, but they're bad for functionality because now you're going to have to log in again to every single website that you're logged into. Okay, so that's why it's, now websites will give you those like, hey, do you want to allow cookies or not? And you can say, I want to allow the cookie that keeps me logged in, but I don't want to allow any of the cookies that track me. Okay, and if the website is compliant with laws in Canada, then it has to honor that. So that's why you see these like dialogues and stuff like that on websites now. And the laws have changed like just even within the last year on that. You can clear it anytime manually. And then, private browsing mode just gives you kind of a fresh cookie jar. Cookies do have an expiration date, but the server chooses it. So if the server wants it to expire in 2050, then it will expire in 2050. And your browser will give you some, so you can control cookies with, say, Safari, and there's different settings in Safari. And Safari's gotten like giving you a lot more options where you can actually kind of go site by site and set specific things. You can control it from the website itself. So if the website is offering you, like, you want these kinds of cookies but not these, you can set it there. And then if you want even more control, you can install special software that allows you like full control over cookies. That's what Ghostry and the EFF one from assignment 2 were. That's what they're supposed to do. Servers can also forget their cookies. So like here, if Google wants to, like say you say log me out to Google, it could go in and delete this cookie if it wanted to. But you don't know because you can't see what Google's storing or not storing. It might keep the cookie, but just say the user's logged out. So you don't really know what exactly, how they implement it. But anyways, the server at any time could also forget your cookie value if it wanted to. Okay, so what do cookies look like? So cookies would look something like this. Let me maybe just demo it. Okay, so I have a bunch of settings, sort of default settings in Safari, and Safari's not going to let every cookie through by default. Okay, so we're not going to see everything the first time I do this, but then I'll try and turn things off and we'll try and get more cookies. Okay, so TSN, we could try. Okay, so TSN, I know it's kind of small, but you can see there's a bunch of different websites there's even popping up now. And these are everyone who wants to set a cookie on my browser. Okay, so if I go to TSN itself, you can see there's a bunch of cookies here. So the name of the cookie or the key of the cookie is the first column. So the first cookie is just called, they decided to call it __ EOI. What does that mean? I don't know. Then there's some value for the cookie. Okay. There's the domain. And this is sort of the domain where you got it from, but it also reflects the domain when I should send it back. And we're going to go through, there's some red tape with this. But anyways, you can see there's a domain here. There's a path variable. There's an expiration date. So these cookies all expire within the next year or two. 2026 is maybe the oldest. If it says session, then that means until I close my browser window, then it will close it. There's a size. And there's a couple flags here, secure, HTTP, and same site. We'll go through those. Now, if I go to some of these other domains, you can see that like these domains wanted to set a cookie. That's why they're in this list. But my browser didn't actually store any of them. Okay? Why didn't my browser store it? Well, it's because they're from a different domain than the domain I was going to. So I was going to tsn.ca. And TSN is free. If they want to let Google try and set a cookie when I'm visiting TSN, TSN can send that cookie to me and say, hey, here's a cookie for Google. And my browser can say, okay, sure, I'll keep it. Or my browser can say, that's a third-party cookie. That's a cookie from a website that's different from the website I'm visiting. I don't want to store it. So my browser right now is not accepting those third-party cookies, and that's why they're all blank. But if my browser was accepting it, then you would see these cookies, and I'll make my browser accept it in a second. Another thing would be this domain is 1v1.tsn.ca. Is that a third-party domain? It's not the same domain as tsn.ca. I'm actually at tsn.ca. I'm not at 1v1.tsn.ca. Okay, those are different domains. They could have a different IP address. They could have a different DNS record. Okay, but on the other hand, it is a subdomain of TSN, so it's probably like kind of owned by the same people, right? So should I allow cookies from subdomains, right? And we're going to have a policy about this. Okay, so right now my browser is accepting those, and we'll go through like the different things that are possible as it relates to domains and subdomains. So right now, I don't have an answer for you right now, but you'll see it in like 3 slides. Okay, now I'm going to go in and I'm going to, I think I can just turn that off and it should. Okay, so now you can see I am getting some third-party cookies, and my browser is now accepting them. I don't know why like some of them are showing up and some of them aren't. But for example, here's Amazon. Well, I assume it's Amazon. I can't say for sure, but it's Amazon-ad system. Let's assume that that's Amazon. So TSN has some Amazon stuff on their website. TSN chose to put that on their website. They didn't have to put Amazon stuff on their website. They chose to do it. And when they chose to do it, then Amazon now wants to set a cookie on my computer, presumably so that it knows who I am because I'm logged into Amazon. And then it might know something about what my history is. And I don't know why TSN has it. Maybe because it has ad system in the name. Maybe some of these pop-up ads, like it's showing me an ad for Mercedes. Maybe that's because I went to the Mercedes website at some point in the past or something like that, okay? Which I probably haven't done, but anyways. Okay, so these are our third-party cookies. Okay, so the stuff on the leftmost are all the domains that are we're getting resources from all these domains. So when I load tsn.ca, I get the root index.html, and then it tells me, go get this from this person, this from this person. And somewhere in the code of that HTML, it's telling me, go to gum.criteo.com and get something from them. And because my browser is now going over to them, then that server is saying, oh, since you're here, I want to set a cookie. Okay? And then it's setting the cookie, and that cookie's coming down with the resource that's coming down from that website. And then my browser's looking at it thinking, I'm trying to load tsn.ca, but I'm getting these cookies from all these other websites. What should I do with them? And then it's deciding whether to store them or not, depending on that setting. that I have. Most websites now weave content together from lots of different websites. A lot of them weave content from things like Google. Why do you weave content in from Google? Is it because you want to trace your users? You want your users to be traced by Google? Probably not. The reason I might have Google on my personal website, I think I do, is because, well, for two reasons. So say again. Okay, yeah. This is different. In this case, it's just as simple as I want to show something off of YouTube. So I have a little widget. It has some YouTube videos. This is actually being populated. This isn't stuff that's on my website, Google. I drew a box and said, Google, put your stuff there. Okay? And so when you download my website, you download this box. Google's filling in what's in this box, or YouTube, which is owned by Google. And so they're giving you cookies as well. The other thing is, let's say I want to know how you got to my website. Okay? I can look at referrers and things like that. But what Google will say is, hey, a lot of users are coming to your website because they search something on Google. We know what that is. If you let us put something on your website, we can link that together. We'll see someone search something on Google, and we'll see them click on your website. Then we'll see that they pop up on your website because they asked for the thing that you embedded, and we can see that they're the same person because of cookies. Then what we'll do is we'll show you all the search terms that are leading people to your website. So people are searching Jeremy Clark Concordia, and that's how they're ending up on my website. Okay, so Google packages this up as like Google Web Tools or Google Webmaster. It's undergone a couple of name changes. But anyways, lots of websites use it because they want metrics on how popular things are and making sure that Google's indexing their websites correctly and things like that. Okay, so that's how we end up where, in a situation where like something like 80-90% of websites have Google embedded somewhere on them. Okay, so the cookies themselves consist of a key value or a name value. So the name is just the tag for the token, and then the value is the actual value. So if you go to the same website, you'll have cookies with the same names, but your values will be different than my values probably for things that are like unique to me, like session IDs. The server chooses this. Okay, so why it's called GADS, but that was TSN, they chose that name. They could have chose something else. The actual value of the cookie, also the server is choosing what it is. And it may be one of two things. It could be just, if it's some sort of session ID, it needs to be kind of like a password, so it's going to be a random number. If it's not a session ID, let's say it's like, I want to see this website in English, then it might create a cookie called lang for language, and then the value of the cookie just might be EN for English. Okay, it's not a secret or anything like that. And so sometimes you can look at the cookies and like I can read the word null. I can read like there's some JSON looking thing here like success true or whatever. Like sometimes you can look at the cookie values and read them. Sometimes they just look like random numbers. Okay, this domain is chosen by the website, and it's the way that the website tells your browser when you should send the cookie back to them. Okay, so I'm going to tsn.ca. I have a cookie where the domain is .tsn.ca. Because TSN is the domain I'm going to, and because the cookie says send me every time you go to .tsn.ca, then I'm going to put that cookie into that request. Okay. Now, if you go through this list, you'll see that the domain looks slightly different. So we have .tsn.ca. Some of them say .www.tsn.ca, and some of them just say www.tsn.ca. Okay. And these are all three are actually different, okay? This one says, send the cookie if the user goes to tsn.ca or any subdomain of tsn.ca. So you can think of the dot here as kind of like a wildcard. So if I later go back to 1v1.tsn.ca, this cookie is going to get sent okay? This cookie will get sent to either if I go directly to www.tsn.ca or go to any subdomain of www.tsn.ca, which is probably a mistake because like no one uses those subdomains. But anyways, that it would technically send if I went to 1v1.www.tsn.ca. And this is for an exact match. Okay, so if I go to 1v1.tsn.ca, this cookie will not be sent. It will say, no, I'm only going to send it to www.tsn.ca exactly. Okay, so the server can kind of control. And I have another slide with other examples of this later. The next thing is you can set a path variable too that says only send this cookie if they're going to tsn.ca/ blah, 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 blah. Okay, and so you can put in like the / whatever, and if that matches, then it will send the cookie. And if it doesn't match, it won't send the cookie. I've never really seen a website that implements this. So it's sort of not used, but it's there if you want to use it. I'll give you an example in the next slide. This is when it expires. Expires means your browser will stop sending it. So when the browser is about to throw the cookie in, it will quickly check the expiration date. If it's past the expiration date, it will not throw the cookie in. If something goes wonky with your computer, and the time on your computer gets messed up, like say you run out of battery and you restart, or there's something weird and it thinks it's the wrong time, then you're not going to be logged into any websites because the time is wrong and all these cookies will be expired, or it'll be a time before they were even set or something like that. And so that's why you get like kind of weird behavior when the time on your computer is wrong. This is just the size of the cookie. And the size is just literally everything you see. And then there's a couple security flags here, okay? So secure, there's 3 actually, I'm just going to talk about these 2. There's a secure flag and an HTTP only flag. So I just flashed the answer, maybe you didn't read it fast enough. What do you think secure means? Yeah, so it has to do with HTTPS, but what specifically does it mean? Okay, so if I'm going to tsn.ca and it's over HTTPS, then I will send this cookie. If I'm going to tsn.ca and I'm not going over HTTPS, I will not send this cookie because the flag is marked. Okay, if I'm going to tsn not over HTTPS, this cookie will get sent because it hasn't marked the flag. Okay, so if there's no flag marked, then the cookie will always get sent. Your browser doesn't care. And if the flag is marked, then it will only send it if it goes over HTTPS. Okay. In general, we like to just turn that flag on everywhere. And most web content is served over HTTPS anyways. But anyways, for whatever reason, not all of these are being set. Probably more like programmer error. Sometimes like cookies aren't working and people just kind of make it the most permissive cookie possible. And they don't necessarily understand. Like it's not like someone's sitting in a room really like there's a big meeting about whether we should turn this flag on or off, right? It's just sort of like, well, let's leave it off. It's more likely to work than if it's on. Okay, then the second one is HTTP only. Any guesses? So this sounds like it has to do with HTTP versus HTTPS. So it's kind of confusing, but it actually has nothing to do with the distinction between HTTPS or HTTPS. It has to do with the distinction between whether your browser is asking for something or JavaScript that's running in your browser is asking for something. Okay? If your browser is asking for something and this flag is set, the cookie will get sent. And if JavaScript is asking, it's not going over HTTP, it's going over this weird XML HTTP. And your browser will say, hey, I can see that that's coming from JavaScript. I'm not going to put that cookie in because this flag is set. Okay? It doesn't care whether it's over HTTP or HTTPS. It's not even considering that in this decision. It's just saying, is the request coming from JavaScript or is it coming from something that the website is asking for that's in the HTML of the website or the user clicked on? Yeah, and so that's it. Okay, why do we have this flag? You're going to see why, but basically it has to do with something called cross-site request forgeries, where You're logged into one website, you go to a different website, it opens up like some JavaScript, and it's trying to like grab stuff from a website that you're logged into, and because your cookie's going along for the ride, it's actually making it into the adversary's website, and then the adversary is going to try and do something bad with it. So that's, you'll see the attack in a bit, but this basically only exists as a flag because of that attack. And then if you turn cross-site tracking or third-party tracking and things like that, then a lot of these cookies will just sort of go away. Yeah, so sorry, that was just an animation showing if I unclick this, which you saw, then a bunch of cookies will be there from third-party websites that weren't there before. Okay, the thing I want to go over, yeah.
In the previous slide, the previous one, when you said when the cookie expires, the browser stops sending it to the website, but it's still stored in the browser.
It might delete it or it might not, but if it's in the browser and the browser's not sending it, it's as good as deleted. So like it, but for space reasons, it probably deletes them just because why keep it around if it's never going to use it? Yeah. Okay, I'm just going to go over the semantics of that. So this path and domain thing, I'm just going to show you exactly how to read these things with some examples. It's a little tedious, but I'll show it to you. Okay, so let's say the website I'm visiting, so right now I go to encs.concordia.ca. So we're always talking about three websites. There's the website you go to that sets the cookie. There's what does the website that you went to put in this domain field. Okay, so what it puts here might be different than the website that you were going to. And then cookies only kick in when you go back to a website. Okay, so there's the website I went to that set the cookie. There's the value that the website put in the domain of the cookie itself. And then there's the website I'm going back to the second time. And between those three pieces of information, we're going to make decisions about whether we should send this cookie or not. Okay, I go to encs.concordia.ca. ENCS Concordia wants to set a cookie with this domain. So my browser might just say, hey, you're not allowed to set that cookie. So that's the first decision. Or it might say you're allowed to send that cookie. That's fine. Now I have the cookie, but what do I have to do to get that cookie sent in the future? Where do I go to get it sent? Okay. So if I go exactly back to encs.concordia.ca, this cookie will get sent. If I go to anything else, like images.concordia.ca, just concordia.ca, so a subdomain of this, the super domain of this, or I go to some completely unrelated domain, the cookie will not get sent. If I put a dot in front of encs.concordia.ca, okay, I am allowed to set that cookie. So encs.concordia.ca is allowed to set a cookie with a dot in front of it. What that means is it will look for an exact match and any subdomain. So encs.concordia.ca is fine. Images.encs.concordia.ca is also fine. By it's fine, I mean if I go to those websites the second time, that cookie will get set. Okay? So the cookie gets set by this website. Inside the cookie is this website, and now I'm going back a second time to these websites and the cookie's getting sent. If I go to the super domain, concordia.ca, if I go to a different subdomain, images.concordia.ca, or if I go to an unrelated domain, then the cookie is not sent. Okay? So the dot here just means any subdomain of exactly this. If anything else about this changes, then it won't get set. Now, what if I want to set a cookie and when the person goes back to concordia.ca, I want that cookie sent? Can I do that? How would I do it? So this website would try to set the cookie concordia.ca here. Okay. So encs.concordia.ca will try to set a cookie that has a broader scope than it itself. Okay. So I'm on encs.concordia.ca and it's saying I want to set a cookie, but not just for myself. I want to set it for myself, plus I want to set it for all my brothers and sisters at concordia.ca. Okay. It's allowed to do that. So browsers say that's fine. You can do that if you want. Okay. So it will be any superdomain and any subdomain of concordia.ca. So it will match to encs.concordia.ca. It will match to images.concordia.ca. It will match to just concordia.ca. Basically, the only thing it won't match to is some domain that's completely different, like canada.ca. Okay? So this is the most permissive thing that you can do. And when web developers don't know what they're doing with cookies and they're trying to debug, they'll turn off all the security flags and set it to the most permissive domain. Now, what if I say, oh, that's really cool. I'm encs.concordia.ca. I can set a cookie for, oops. I can go up a domain and set a cookie for it. Could I go up another domain to the top level domain, and could I just set a cookie for .ca? Okay, and so the answer is sort of like the browser has to decide, and the browser is going to say no in this case because it's kind of dumb, right? It's true, that cookie will now get sent to every website you go to that ends in .ca. So if you do own crave.ca, bellmedia.ca, and tsn.ca, you will be able to share cookies between those three websites, but you're also sharing your cookie with every other .ca. And it just creates so much volume and spam that the browser said, no, we're not going to let you do that. Okay? Browser decision, browser policy, they decide, no, we're not going to let you do that. Now, what if there is actually a specific domain that you want to share your cookie with? So you're concordia.ca and you also own mcgill.ca or whatever. Could concordia.ca set a cookie for mcgill.ca? Okay. So the answer is no. Your browser is basically not going to accept this. Okay, so you cannot set your cookie for something other than yourself, a subdomain of you, or a superdomain of you. This is a third-party cookie, sort of in a sort of slightly different sense. There's third-party cookies where I'm visiting the website encs.concordia.ca, but there's a picture from images.google.ca. My browser is actually going out to images.google.ca. It's getting the image, and then that server is trying to set a cookie. So that we sometimes call that third-party cookies as well. So the terminology is a little loose. But anyways, this is another way of thinking of a third-party cookie. It's generally not allowed. Okay, then the other thing is there's this path field. So this is how it works. So in a cookie, I could set the cookie to encs.ca. And then I could also set a path like /tilde-clark. Okay. Then if you go to encs.concordia.ca/mmanon, this cookie will not get sent. But if you, I didn't have the, I should have the extra line. But if you went to encs.concordia.ca/Clark, then the cookie would get sent. Okay. So it only gets sent to that exact domain plus that exact path. Okay. Anyways, path variables are basically not used for cookies, but they are there. They're in the spec. You can set them if you want to set them. The tilde? No, it's just like how Concordia does personal websites. They just put it as tilde. Yeah. Okay, so just at a high level, just again to reiterate, I know we keep going over this, but anyways, I go to tsn.ca, TSN sends me index.html, okay? I take a look at index.html. So I'm reading through index.html, and as I'm reading it, it's saying, go over to Google and grab this JavaScript. go over to Snapchat and grab this ad library or this widget, like whatever. Go to DoubleClick and grab this ad. Go to Twitter and grab the picture of the button with the follow button. And if someone clicks on it, have the JavaScript so that they'll follow me on Twitter if they click on it, okay? So all of this is getting weaved into index.html. My browser isn't showing me, like my browser just shows me that I'm at tsn.ca. Like even though I'm getting all this stuff from all these websites, when I look up here, it just says tsn.ca, okay? I don't know that this ad library came from Amazon or Google or whatever. Like I have no way of knowing where all this content is coming from. It's all getting weaved together, and my browser's just saying this is tsn.ca, okay? Now, as I do these requests, my browser will, for every individual request of a resource, it's going to go to the cookie jar, and it's going to, if it finds that I have a cookie for Google, it will throw the cookie in. If I've never gone to Snapchat before, it won't throw the cookie in. And if I've gone to Twitter before, it will throw the cookie in, okay? So all it does is it looks at where I'm going. It goes through the cookie jar. It says, looking at that domain that's in the cookie jar, does it match the website that I'm going to? Does it match google.com? So any cookie with google.com or .google.com in its path name, or sorry, it's a domain name, will match, and then I'll throw the cookies in. The browser will throw the cookies in, okay? And then it will also check whether it's expired. If it's expired, it won't send it or delete it. And then it will check the security flags. Okay, so if this request is from JavaScript within this website and HTTP only is set, then it won't send it. Or if this request to doubleclick.com is not over SSL and the secure flag is set, then the cookie won't get thrown in. Okay, so all of this lets us do certain things with cookies. So we can do things like keep users logged in, so session IDs. We can remember things about users, like I always want to see this website in English. Okay, so you can have sticky settings. As long as you're coming back from the same browser, same device, it will work. And then on the sort of bad side, you have tracking. Okay, this is why there's laws and regulations about cookies, is because of tracking. So the way tracking works, this is sort of what that video was about. I send a request, say to Lululemon, I'm looking at some shirt. I'm like, I want that shirt or whatever, it's a nice shirt, okay? What will happen is when I go to this website, Lululemon might have a relationship with an ad agency or someone that's tracking. They're maybe paying Lululemon money because they're allowing people to track them. They might be giving them services. They might be allowing them to, they might be serving ads. Usually you wouldn't have an ad on a clothing company because it's basically just ads anyways. Or it could be giving some web tools. Who knows what the relationship is, okay? So let's say Lululemon has this like relationship with this agile1.com, okay? When index.html comes down, I'll look at this, and the index.html, which is Lululemon created that. They created that file. They created everything in it. They tell me, hey, go request this JavaScript from this website, agile.com. Okay? So my browser will say, fine. It will go find the DNS for agile.1.com. It will find the server IP address, and it will say, I want JavaScript ping.js. By the way, because Lululemon knows what actual shirt I'm looking at, because this shirt has a unique URL, and this unique URL has like an item number, like they call this shirt number 9483 on their website, okay? They can pass that along to Agile 1 if they want. So they might throw it in as a parameter. So Agile 1 is saying, oh, this person is requesting this ping.js. And by the way, the exact website they're on right now is shirt 9483. Okay? I'm just going to remember that. All right? Now, I'm going to ask the user to set a cookie. So I don't know who this user is, haven't seen them before. I'm going to say UID equals 55, and I'll send them back to JavaScript, which is what they were asking for. Okay. Later, what will happen is I'll go to CBC. All right. And so I'll say, CBC, give me the news. And CBC says, great. Here's the news, index.html. Start constructing it, pull in all the images and the videos and stuff. And oh, by the way, we use this ad library from agile1.com. So go over there and get this ad.js from them. Okay. So my browser is about to go to agile.com, and it's about to ask for an advertisement from agile.com. But before it sends a request, it's first going to check its cookie jar. Okay. And say, do I have a cookie for Agile 1? Does it have a cookie? It does, okay? It has this cookie 55, so it's going to drop this cookie in and send it. Now, what does agile1.com know when it sees this request for ad.js? Okay, so it knows, hey, I've seen this user before because they're coming back with a cookie. I'm going to go back in my history, and I wrote down maybe up in this interaction that, hey, when I set this cookie, the user was coming to me because they were shopping on Lululemon and they were looking at item 9483, which Lululemon conveniently passed to me. Okay? So what advertisement are you going to see on inside ad.js? Right? They're going to show you like the exact same shirt, basically. Okay? So Lululemon likes this, because now you're on cbdc.ca. Maybe I've been thinking about the shirt and how much I like it, but then I kind of forgot about it. I started doing other things, and now I'm getting that reminder. Okay? And they're not just showing me, it's not just like, oh, you've gone to Lululemon, maybe you like the brand. It's like I'm showing you the exact shirt that you were looking at, right? And so anyway, so this is how targeting advertising works. It's how it can track you across multiple websites, but the common denominator has to be this Agile 1 or something like it where it's on all the websites, okay? So all the individual websites have to have a relationship with the same company, then you can get traced across websites. If that's not the case, then you can't get traced. Okay, questions about this? Okay, good. So let's take a 10-minute break, and then we'll go through the rest. Okay, there's not too much left to go through, actually, but I want to go through cross-site requests. And then there's an attack called cross-site request forgery that is a consequence of sort of how cookies work. Okay, let's say that I go to cbc.ca, I download index.html, I start opening it up, and CBC says, hey, we want you to go over to Facebook, and we want to grab this like button. Okay, so a like button's like a thumbs up button. It's a picture. It's some JavaScript that goes along with it. And why is CBC doing this? Well, they want that if I'm reading an article on CBC, I click the like button, which is supplied by Facebook. That will somehow get registered with Facebook that I like this specific article from CBC. Maybe Facebook on my Facebook profile will now say, Jeremy likes this article, and it will have a picture of that article. Okay? Now, this is the kind of functionality we like on the modern web, okay? The fact that websites can sort of work together, that even though you're on CBC, you want to do something on Facebook, you don't have to go all the way over to Facebook and copy and paste the URL. You can just do it directly from the website that you're already on, okay? So things like cookies and scripting and things like that allow allow you to like weave together websites that are complicated that let you do this kind of thing. Okay, so let's say that Facebook has a bunch of cookies that are set, and let's say that I have already logged into Facebook. Okay, so Facebook knows that it gave Alice cookie number 55. So when Alice requests the like button script, she sends along cookie number 55, and Facebook's like, okay, I know who you are, you're Alice. Okay, it sends the like button back. Then if Alice clicks on the like button, okay, again, it will send something to Facebook. Like the like button will be programmed so that when you click on it, it sends a packet or a request to Facebook. Facebook will see it. It will say, I know that's Alice. I can see that Alice is logged in. Then it can go and it can update Alice's profile, and it can add the fact that she liked this particular article from CBC. Although in order to know what article it is, CBC would have to be passing this information to Facebook. Okay, so when in index.html, when they request this like button, you should have like an @ parameter and then the article ID, so that Facebook knows what article it is, and then the whole thing works. So maybe these slides could be improved a bit with more detail, but imagine it's sort of like in the previous example, like with this actual parameter on the end that's telling Facebook which article it is, okay? Or it might be when you actually press the like button that it sends along the article ID to Facebook. Okay, so this is called a cross-site request because I'm requesting something from Facebook while visiting cbc.ca, okay? These aren't the same website, so it's cross-site, and we have 2 requests, and so that's why the term XSR comes in, cross-site requests. Cross-site requests are not bad. You might have heard of cross-site request forgery. Maybe you haven't heard of it. It doesn't matter if you haven't. But if you have heard of it, you might think, oh, this is the bad thing that this attack is based on. This is not bad itself. This is good, okay? It's when you add the forgery on the end, right? That's when it turns into attack. Okay, so to use this as an attack, it's helpful to just think about what these like parameters on the ends of URLs are actually for, and why websites use them. Okay, so let's say I go to I can actually like demo this as well. Okay, the problem is Safari's smart, so it doesn't actually show me the URL because it knows I'm on Google. So I will go to some weird search engine that nobody uses ever and do the same thing. Okay. All right, so I'm on CF Montreal. I'm going to go to the second page of results. All right, so let me ask you a question to start with. I'm on this website. Okay, this website, everything you see was set by Bing, so they decided what this website looks like. They might have drawn a box and said, YouTube, fill this box in. Okay, so like they don't necessarily know all the content of the website, but they at least drew the box and told another website to fill in a particular box. Okay, so this is all under control of Bing. Now, if I go to the second page of results, it shows me the second page of results. That's sort of an obvious thing, okay? But how did it know that? How did it know that I'm the person that was just on the first page of results and now I want to see the second page of results? Okay, or if I press this button, how does it know go to the third instead of going to the fourth or the fifth?
Maybe when you press something like 1, 2, 3, 4, 5, it gets passed to the URL.
Okay. So let me give you 2 possible answers. So I'm going to play with your answer second. The first possible answer is it could be cookies. So like it knows who I am, so it has a cookie, and it just writes down, oh, user 55 is on the first page of results. Then I click the next button. It gets this request. It has the cookie 55, and it says, okay, I know who this user is. I saw that they're on the first page of results. I see they want the next results. So I'm going to give them the second page. That works. There's nothing wrong with that at all. Okay? So that's one way that these websites might work. The second way they might work is there might be something in the URL that's telling it that it's the second page. Okay? Now you described it as passing something from here to the URL. Is that possible technically? Can me clicking on this pass something up into the URL?
H, yeah, the tab.
Okay, so it's already in the URL. Okay, so the URL that I request when I click on the fourth page, it's already in the HTML of this file that I'm already looking at. Okay, so what Microsoft says is you're on page 1. Let's just go back to the original. I'm going to give you a button on this page that will go to page 2 of the results. Okay, I'm going to put the link, the URL that you should visit if you click this button. You don't have to click this button, but if you click this button, you're going to go to a certain URL. I'm choosing that URL when I give you the page that you're looking at. So when they choose the URL, they're going to choose to have the parameter page results equals 2 in the URL. Okay? Then I click on it. My browser sends a request. The name of the request is going to be, results.php ? Results page equals 2, search term equals CF Montreal. Okay? Now the website doesn't have to remember that I'm the same user that clicked on this previous thing. Everything is in the URL itself. Okay? What I was searching for is in the URL. What page of the results I'm on is in the URL. And so the server doesn't have to remember anything about where I was. Okay? So we call this, it's called RESTful, but the key idea of it is it's kind of stateless. So when I ask for search ? Query equals soccer and page equals 10, it doesn't have to remember that I was on page 1 before. It just says, okay, well, give this person page 10 of this results. Okay? So it's not tracking you through the website of like, I started here, then I went here, then I went here. It's just, it's putting the tracking information in the URL itself so that when it gets a URL, then it knows what to send you, like all the information's in the URL itself. And it doesn't have to remember anything, okay? Now, let's say I search CF Montreal. I'm here on the 5th page of results. I grab this URL and I send an email to you and I paste that URL in. You click on it. Where will you go?
On page 5.
Yeah, you'll search for CF Montreal and you'll go to page 5 of the results. Okay? Is that because you searched and you started on page 1 and then went to page 2? No, the website doesn't know that. It doesn't know anything about the history. It's all in the URL. So it will just jump you directly to that thing. Okay? So you could give that URL to someone else. When they click on it, then they'll jump to the exact same place that you are. Okay? So websites sort of lose track, or they purposely don't try not to remember anything about where you are. They just kind of put it all in the URL, and that's how they track where you are. And they control all the URLs when they give you the HTML website. So they'll rewrite the website with all these parameters in the URLs. So that's how they track it. Okay, does this make sense so far? Okay, now what we're going to do is we're going to put this together and this together. So we have cross-site requests. Okay, so the idea that you can go to other websites. You go to one website and it can ask you to load other websites. And if you have cookies, those cookies are going to go along for the ride. Okay, so that's thing A, which is not a good thing or a bad thing, or it is a good thing. Thing B is we like websites where we don't remember anything about where users have been. We just jump to directly what the URL is telling us to do. Okay? All right. So let's say Alice goes to a bad website. How does she go to a bad website? Well, I don't know. She gets an email, a phishing email or something like that, or there's some like urgent like message or something. She just clicks on it. Okay? Should you ever click on links to bad websites? No, you shouldn't. But might you do it accidentally? Sure. Okay. And in general, like just clicking a link to a bad website shouldn't be dangerous for you. There's something wrong with the web if all it takes for like something bad to happen to you is you click on the wrong link. Okay. So this is a story of something that's bad with the web that happens to you if you just click on a link. So all Alice says is she accidentally clicks on this link. Okay? So the website says, okay, here's an index.html. Alice's browser opens it up, and this file is going to tell her to load a bunch of resources from other websites. Okay? One of the websites it will tell her to go over to is bank.com. Now we're going to assume that this is actually Alice's bank. We're going to assume that Alice is logged into her bank. So when this request goes to the bank, Alice's cookie goes along with it, because this is just any request to that URL and it matches the cookie. Okay? So when the bank receives this request, it looks like it literally came from Alice. It says, I know who this person is, they're logged in, I know exactly who they are. Okay? Now, because of RESTful architecture, the adversary might create a URL that looks something like this, like transfer 100 from Alice to Eve. Okay, it wouldn't be that simple, but whatever. Now, a banking website might do that. So normally you would create a transaction, like I want to send you money, I would fill out the website, and then I would press a button. But what the website's going to do is it's going to pack that into a URL. It's going to send it in the URL form, because it doesn't want to remember what was the site I was on just before I sent the transfer and all of that type of stuff. It just looks at the transfer. It says, I know who this came from. It came from Alice. It doesn't know that it's embedded into evil.com. Okay? It doesn't know that Alice didn't just, in one version of the world, Alice logs into the website, she clicks her checking account, she says move money from this checking account to this. She goes through all the steps, and the website might track her all the way through. In this case, the only thing that's weird about this is she's jumping straight to the transfer. Okay? But the whole point of this is we don't want to keep track of where the user's been, because we have to store it somewhere, and that takes up memory. Okay? We want to just jump directly to what the user wants to do by looking at the URL. Okay? And so what will happen is, what did happen for a long time is the bank would do this transfer. Okay? It would work. And it might not be a bank transfer. It might be posting spam on your Facebook account or following a particular account on Instagram or whatever the case is. Okay? You just click on the link. It sends the instruction that it wants you to do in a URL. You happen to be logged into that server. Alice, or the evil person Eve doesn't necessarily know Alice. It's just guessing blindly. It might have this for every major bank, right? It might get her to go through all the banks and do it, and then whichever one she happens to be logged into, it will go through, and the other ones will just say, I don't know who you are. Okay? And so this actually works. Okay? So this is called a cross-site request forgery. This is bad, obviously. So how do we stop it? So now we want to fix it. And first off, who's going to fix this problem? Okay, so there's maybe two answers. So one is the browser is going to fix it. Okay? Evil.com is obviously not going to fix it, but bank.com might fix it as well. Okay? So whose fault is this? Between bank.com and the browser. Okay, maybe. So the way that the browser implements its cookie policy, where it just sends the cookie indiscriminately to any, website, it made that decision. That's its policy. You could say the browser's at fault, or you could say the bank is pretty dumb by letting you just looking at a URL and say, okay, I'll transfer $100,000 because I looked at this URL. Okay, so you can come down on either side. Let's say the browser wants to change its cookie policy, so it doesn't want to send this. If it doesn't send this cookie, then this attack doesn't happen. Okay? So it might say something like, I'll send cookies, if you're at evil.com, I'll send cookies to evil.com, but any other subdomain that's loaded by evil.com, I won't throw those cookies in. That could be a cookie policy that a browser decides to do. If it does it, it prevents this attack, but it also prevents good things. So it also prevents this kind of thing, right? Now Facebook can't have the like button on CBC and you can't click on it, okay? So it's your choice. So you can have a interactive web that's cool and like weaves content together, but if you have that, you also get this that goes along with it. you can stop this, but then you're going to stop a lot of things that developers want to do, building cool websites. Okay? So the answer was sort of that bank.com should change. Okay? Now, bank can go back to the way it used to do it, which is it wants to see the user log in with their username password. It's going to write down that they did it. It wants to see them click on their account and then go to the transfer website and then fill out the form, then submit the form. And because it can check that full history, it knows it's not getting like parachuted in from evil.com. Okay? The problem with that is the bank also still wants this RESTful architecture. It doesn't want to keep all that memory. Okay? So can we have the best of both worlds? Can we somehow stop this attack from happening? And we can have the bank so the bank doesn't have to remember everything. It can still literally just look at a URL and decide to send $100,000 because the URL tells it to. Okay? And so the answer is it can solve it. And actually the answer, first off, there are more than one answer. So there's different ways of solving it. But this is the most common one. It's very elegant. It's very simple. When you look at it, you might be deceived by how simple it is because it looks so simple. But it actually is like pretty ingenious. But this is what it does. All the bank will do is it will say, I'm using this RESTful architecture. Okay? So if you send me the right URL, I will follow the instructions of the URL. But one of the parameters I want to see on the end of the URL is your cookie. So it will add a parameter called user ID equals the cookie value. Okay? Now, does evil.com know the cookie value? It doesn't. Okay? Even though the cookie value is sent here, it's not being sent to evil.com, it's being sent to the bank.com. Okay? So evil doesn't know the cookie value. Can evil create a URL here with the right cookie value on the end? It can't do it because it doesn't know it. And if it knew your cookie, it could just log in. It could just session hijack you anyways and do the transfer. As soon as it knows the cookie, it's over. The whole point of this attack is, can I get you to use your cookie even though I don't know what your cookie is, and even at the end of the attack, I don't learn what your cookie value is. Okay? All right. Now, so that's great. That will prevent the attack, but then we have to think, like, does it still work for the bank? Okay? So can the bank put this value onto the end of every URL it sends you? Okay? So the first time you go to the bank, it won't have that parameter on the URL, but you will send a cookie or it will ask you to log in if it doesn't know who you are. Okay? So the first website you get, it will say, okay, I now know who you are. You're this cookie value. Maybe I know your username password. Then it controls the URL. All the URLs that you click on, you're clicking on them because they're in the HTML of that website. Okay? They're the links, the URLs on the links in that website, and that website was given to you from the bank, and the bank knows your cookie. So what the bank will do is it will rewrite all the URLs on the website, and it will put that cookie value on the end. Okay? So when I go to the bank, all the URLs that I can click on will have my cookie value in it, and when you go to the bank, all the URLs will have your cookie value that are in it. Okay? So the bank is able to do it. It's still able to use this RESTful architecture. It just checks the cookie on the end. And then it does a very, very simple check, which is the browser sending a cookie, right? So it's getting the cookies two ways. It's getting the cookie in the header of the request, and it's getting the cookie in the actual request itself, okay? And all it's doing is just checking whether they're the same. If they're the same value, then it must be the user. And if the adversary takes a guess at your cookie and gets it wrong, then this cookie here won't match the cookie here, and then the browser will say, I'm not accepting that, I'm not doing the transfer. And if the adversary sends it without the cookie, then the same thing will happen. It will say, I don't recognize that cookie, there's no cookie there, so I'm not going to do the transfer.
But what if they get it right?
What if which?
What if they get it right?
If Eve gets your cookie value, right? Okay, first just notice that there's no way for her to get it, right? At least from you visiting their website. So when you visit eve.com, you'll send all your cookies related to eve.com, but your browser will never send your cookies for bank.com to evil.com. That's because of the cookie policy. Because those domains don't match, it can just never happen. Yeah? So there's no direct way for it to do it. The only way it could get it is through some other attack, right? But then, like I said, if it could get that value, it could session hijack you anyways. Yeah. So it's, yeah. Okay, so this attack is sort of complicated, and the defense against it looks simple, but it's sort of complicated to sort of convince yourself maybe that it works. But it does actually work, and it does actually prevent the attack. Are there questions about the attack or cross-site requests or the prevention mechanism? Okay. So in summary, cookies are sort of good because they keep you logged into a website. They can personalize the features of the website, and they can give you a Facebook like button. They're bad because if I can steal your cookie, I can steal your session. I'm basically you. We talked about this before. So like, I would rather, if you gave me the choice of having your cookie or a password, I would take your password as an adversary. Because your password, it will last for a longer amount of time, and I can do things like reset your password. A lot of websites now, they'll let you do certain things with just a cookie, and they won't let you do other things without logging in. And then from a privacy perspective, cookies it lets companies track you across websites and serve you ads and things like that. Okay, so that's all I had to say. Any final questions? Yeah.
I saw Chrome does not have the RESTful feature, at least on mine.
Okay, so RESTful is the website decides it. It's not the browser itself.
No, but I did search safe one.
Yeah, it should have it. It's just, you mean like Google search doesn't have it?
No, Chrome browser. Like
Yeah.
when I search, Google search basically.
Yeah,
But when I used Bing,
yeah.
I did get the 1, 2, 3, the page.
Yeah, right. Yeah, so Bing does it, but I'm pretty sure Google does it as well. It's just, Safari knows that I'm on Google, so it's not, here, actually, okay, here's the full URL. Yeah, it doesn't like showing me that full URL, but you can see it has that like client equals Safari, IRLS equals N, that means my language is English. What I searched for was CF Montreal, and then it will go down the line and there'll be a bunch of other stuff.
No, I'm just saying that there's no page like option. It just goes on and on, more results.
I see. Okay. Sorry, I didn't understand what you mean. Yeah. So anyways, the page is just an example of the kind of thing that you might pass in one of those UR parameters. But yeah, you could code a website without pages like this one. So you couldn't jump to that page. But if I want to show you the search results for CF Montreal, I can just send you, let me get rid of all this crap at the end. So let's say I send you an email, and this is the only URL that you have. Like, this is what's in the email. You click on it, it's going to take you to this result, right? How did it know to show you these results? Well, it's in the URL itself, kind of thing. Yeah. And so Google works the same way with the search terms. It just, I don't know what the syntax is for it. But. Oh, actually, here, let me just see. Q equals CF Montreal. Yeah, so I think this is right. So if I were to conversely send you an email like this, and then you click on it, then it would do the same thing. Okay, other questions? Yeah.
What about XSS? Is it about cookies as well?
Which the,
XSS?
no, it's not about cookies. It's about something called the same origin policy. So the same origin policy will be the full topic next week. Yeah. So there's two attacks that look kind of similar. One's XRSF, cross-site request forgery, and the other one's XSS, which is cross-site scripting. And so cross-site scripting is sort of the complementary attack for scripting. So today's class was about cookies. Forgery is cookies. Next class is about scripting, and I'm going to show you 6 different kinds of XSS attacks next class. Yeah. Or something like that. Yeah.
Next class is
Oh, yeah. Thank you for reminding me. So everyone, there's one class remaining, and it's on Tuesday. Why is it on Tuesday? Well, this is technically the last day of classes, except for if you have a Monday class or a Friday class because of Easter holiday. So all your Monday classes are being rescheduled for Monday, which makes a lot of sense. But then instead of waiting till Friday next week, they decided, well, we'll just put Fridays on Tuesday, and then Wednesdays we can start exams. Okay? So same room, same time. If you have a Tuesday class, you're done. Like the class this week was your last class for Tuesday classes. And so next Tuesday will be for any Friday classes, and then after Tuesday it will go into exams. Okay? So same time, same room. It's just on a Tuesday instead of a Friday. And we'll be talking about the exciting topic of the same origin policy and cross-site scripting. And I'll be answering all your questions about what's on the exam and showing you a copy of the exam so that you can get a head start. Just kidding, I won't do that. I haven't even written it yet, so don't get your hopes up.